How about boiling point elevation? Well, you're probably anticipating the solution to that. Let's first give the intro-chem equation. The boiling point elevation is the molal boiling point elevation constant times the molal concentration. This again, remember, is the solute concentration. Okay, so where does that come from? Well, again, we'll just use the analogous argument that we used when we talked about the temperature dependence of solubility, and we used that for freezing point depression. We're going to use it once again for boiling point elevation. So here's the solute. I guess we're calling this a solvent, be consistent with our previous picture. There's our solvent molecules, and then we have solute, which is the open circles. Now when we boil something, what happens is that we go from the so-called liquid state, so I'm assuming that the solute here is in the liquid state, the solvent is the liquid state. We're looking at the boiling point of the solvent, so just let's consider the solvent. So what you have to do is you have to take that out of the solution and put it into a gas. I hope I can convince you that it's just like we had before, at the natural log of the mole fraction of the solute. But now instead of going from the solid to a liquid when we freeze it, we're boiling it, so we're going from a liquid to a vapor. So therefore this comes out to be delta H of vaporization over R, 1 over the boiling point of the pure solvent minus 1 over boiling point of the solution. We'll do the exact same things we did before. We'll do the Taylor series expansion here. Oh, sorry, we're looking at the solvent. So clearly I'm hallucinating. This is the mole fraction of the solvent because that's what we're measuring the boiling point elevation of. So we'll do the same thing. Taylor series expansion gets rid of this. Let's put some minus sign there, but that'll cancel out here. So the mole fraction of the solute, and again cross multiply and so on, is the enthalpy of vaporization over R times the boiling point of the pure solvent squared times delta T, where delta T here is T minus TB, boiling point elevation. Note that the boiling point goes up, so delta T for the boiling point is greater than 0. On the other hand, we'll just go back here and see how we define delta T. So the freezing point goes down, so delta T here is negative, less than 0, because the freezing point is depressed. Okay, so there's different definitions of the delta for freezing point and boiling point elevation. Okay, and then we make the conversion to molal, so we get so delta T, the boiling point elevation, is these things times the molal solution concentration. And we call this Kb. And again, in order to get this relation, we had to assume a dilute solution where the molal solution concentration can be easily calculated from the mole fraction, and also where the boiling point of the solution doesn't differ much from the boiling point of the pure solvent. So there we have it for boiling point elevation.